Hi and good day, sir. We are from the group The Net Herd, and we will present on the group project 2, which is on the performance comparison of neural network. So the group members are Intan Rafina, which is the leader, Maisara Amir, and also myself, Nur Anis Nabiha. So next is the table of content that what we will present, which is in the introduction, tasks 1, 2, and 3, followed by discussion and conclusion. So for the introduction, the two-layer neural network is a class of feed-forward artificial neural network, and this consists of layers of nodes, input layers, hidden layers, and also the output layer. And for the LeNet-5, this is also a type of convolutional neural network architecture that is made up of 7 layers that compose of 3 convolutional layers, 2 subsampling layers, and 2 fully connected layers. And this type performs well in a large-scale image processing, and this network was a starting point for a large number of neural network architectures. And last but not least is the AlexNet. It is also a type of convolutional neural network architecture for image recognition, and this contains of 8 layers, where the first 5 were convolutional layers and some were max pooling layers, and the last 3 were the fully connected layers. And this uses the ReLU activation function, which showed the improved training performance over 10H and sigmod. So for task 1, the performance are compared with using two-layer neural network and also the LeNet-5. So after the running of the codes, these are the values of the training accuracy, training loss, validation accuracy, validation loss, and also the test accuracy and loss. So to put side by side, it can be seen that the LeNet-5 gives a much improved accuracy. For example, for the training accuracy, the LeNet-5 gives 0.8972, meanwhile the two-layer neural network gives 0.8760, which is much lesser than the LeNet-5. And also for the loss, LeNet-5 shows a much smaller loss compared to the two-layer neural network. And here is the results for the task 1. Both are tested using the same image and same number, and both gives the right answer. But as can be seen from the previous slide, that LeNet-5 gives a much better accuracy.
Okay, so I'm Intan and I'll be talking about the test 2. So what we did was that we compared between the two-layer neural network with the LeNet-5. So for the two-layer neural network, the training accuracy is 0.4293, the training loss is 1.6311, the validation accuracy is 0.4058, and the validation loss is 1.6872. So the test 2 test accuracy and loss is that it results to a test accuracy of 0.4119 and a test loss of 1.6616. So meanwhile, for the LeNet-5, we gained a training accuracy of 0.7585, a training loss of 0.6973, a validation accuracy of 0.7084, and a validation loss of 0.8575. Okay, so the test accuracy and loss of the LeNet-5 is that the test accuracy is 0.6956 and a test loss of 0.9018. Okay, so to compare between the two models, the LeNet-5 can be seen that it has both a higher training accuracy as well as a higher test accuracy, which means it is the better choice of model between the two.
Now is the overview of task 3. Firstly, recreate the AlexNet model to improve the model accuracy. Then, compare the custom model performance with result in task 2. Moving on to the AlexNet coding, we have changed the hyperparameters values such as the kernel size, stripe value, and epoch. We also included dropout function. Its function is to prevent overfitting of the model. Next is the accuracy and loss of the training and validation. The training accuracy is 0.9723, while its loss is 0.0821. The validation accuracy is 0.7012, and loss is 1.7911. The epoch was changed to 20 to accommodate a higher training accuracy. This unfortunately increased the training time. After the data has been tested, its accuracy fall into 0.689 with a loss of 1.8636. We have tested the model with the same picture from the previous task. Due to high training accuracy, it managed to give the right answer, which is dog.
Okay, so I'll be talking about the comparison of the model between for the task 3, which is between the task 2 and AlexNet. So as you can see, that the training accuracy of AlexNet is the highest, which is 0.9723. But unfortunately, it has lesser testing accuracy where it falls below the Net 5, where AlexNet is 0.689, but LiNet 5 is 0.6956. So the lesson that we learned in this assignment was that we learned on tuning the hyperparameters such as filters, kernel, strike, and epoch, which helps to obtain a higher accuracy. It also allowed us to explore the difference in the three models, between all the three models. And the last lesson that we learned was that just because a model has a high training accuracy, it does not mean that it also has a high testing accuracy, as we can see from the LiNet 5 when compared to AlexNet.
And finally, the conclusion. First, we successfully compared the performance accuracy of the neural network NN model and the CNN LiNet model. Second, LiNet 5 has a higher performance accuracy compared to the neural network model. And last but not least, customized AlexNet has higher training accuracy due to the high number of trainable parameters. Moving on to the member duty. So Nur Anis Nabiha did the introduction of two-layer neural network, LiNet 5 and AlexNet. She also did task 1 training and testing of the model, task 1 result, as well as slide presentation. Inta Rafina Shazrin did the task 2 testing and training, task 2 result, assist me on task 3, slide presentation, as well as video presentation editing. And finally, I did the task 3 coding, task 3 testing and training, task 3 result, slide presentation, and conclusion. That's all from us. Thank you.